Okay, good morning. Good to be up here again to share a little bit about what we're doing in our exciting program. First off, I want to just, I always forget to do this every year, but I just want to introduce the players of this program just really quickly. Of course, yours truly, myself. I'm actually doing a 3-for-1 special today. I'm going to actually have 3 topics in this talk, and we're going to go through each of these 3, hopefully within the 20 minutes that I'm allotted. I am the coordinator of the Lunar Meteoritic Impact Search section of ALPO, so I'm going to give a brief update as to what's new in lunar meteor impact studies. Mahmudir Rahman, he's one of our graduate students. He's actually an electrical engineering PhD candidate, and he's been really instrumental in working with our program. Prem Kumar Sigante, he's the program coordinator and the principal investigator of the Radiation Institute for Science and Engineering, which is a research lab that we've established about 4 years ago, and he's also the PI for the Observatory project, which I'll talk about in just a few minutes. And then Gary Erickson, of course, he's been helping out with a lot of things in the department. I play a multifaceted role in our physics department. I'm informally known as the resident astronomer, since I'm the only person that has a pure astronomy degree. I also coordinate the physics and physical science labs. I teach classes, usually a class or 2 per semester. I help in the administrative detail, especially at the beginning of the semesters, etc. Haven't had time for much research in recent years, but hopefully that will change in the coming years. Prairie View A&M University is what's called an HBCU, a historically black college university. Most of the students are black, but we do have students from all over the world and all over the country attending our university. The little seals that we see along the top of this introductory slide are the partners in this satellite project that I will talk about a little bit later. We're getting ready to launch another satellite with the help of JAXA, and of course we're also working with the Kyushu Institute of Technology in Japan and NASA Johnson Space Center. So, let's see. Okay. So the last 2 talks were especially interesting to me, since one of the things that I do is manage the Solar Observatory, and this is what the Solar Observatory looks like in its present form. Actually, this is what it looked like just before we did the renovation of the exterior and the lower level of the interior. We're actually going to move on to refurbishing the telescope itself, which has fallen under a state of disrepair. This observatory had been active in the past since 1998. As a matter of fact, I had observed on it full-time for the first 3 years of my nearly 20 years at Prairie View A&M University. We were focusing on active regions, prominences, and so forth. This is actually the starting point of a much bigger project that I will get to in just a few minutes. So, going back to putting on my ALPO hat now, being the coordinator of the Meteoritic Impact Search section, I want to just bring a brief update as to what some of the latest events that we were able to record. I partnered with Cudnik of the British Astronomical Association, and we had set up an event where we got people around the world to observe the moon for the impacts of lunar geminid meteors. And so we actually were able to get 5 confirmed meteor impacts on the moon, including a group in Greece that is running a 1-meter telescope. It's a group called Nel Iota, and it's in the midst of a 22-month program in looking for faint meteoroid impacts. The reason why I have Jupiter on here and not the moon is that one of my ambitious goals for this new observatory at Prairie View is to set up a patrol to keep an eye on Jupiter, not only to follow its weather patterns, its changing weather patterns, but also to monitor the planet for meteoroid impacts, such as the one that's seen here near the top of the image. This was taken by Saviao Pedraghelou in France. This was recorded actually a little over a year ago at 21:24 Central European Standard Time. This was actually 12 minutes before sunset. By the way, that's one of the best times to observe Jupiter, is just after sunset as it's getting dark because of the contrast with the fading twilight. So this is an image from Nel Iota of one of the impacts. You can see the impact in the red box, and also the 2 smaller images show what the impact looks like in the R filter and I filter. They actually observed this in 2 filters, and notice that the I image looks brighter than the R image. These impacts give off most of their lights, most of their flux in the infrared. So this is the quick shameless plug that if you're interested in getting involved in such studies, we're still active at the Lunar Meteoritic Impact Search section, and we can always use observations, especially during times of major showers. And of course, you can subscribe to the Lunar Impacts listserv, or talk with me after this talk for more information. So again, the Prairie View Solar Observatory was established in 1998, and that was the reason why I came to Prairie View in the first place, was to work on the solar telescope. What this is, it's a 35 centimeter, or about a 14-inch Gregorian solar telescope. And its vacuum, the top part of the tube is evacuated so as to minimize distortion from seeing. So currently we have the main telescope, which is able to focus on a region of the sun about 7 arc minutes across. So that's enough to capture an active region and or part of a filament structure. Observations also included solar flares, prominences, filaments, and the occasional planetary transit, specifically the transit of Mercury in November 1999. The facility, unfortunately, is in disrepair, but a grant from the Department of Education has helped us to begin refurbishing this telescope and the observatory, and we're in the process of bringing it back to life. There were a number of professional papers and conference posters that were produced during the peak of Prairie View Solar Observatory's production, and I was co-author or author of a few of those papers. The latest is that we are moving forward with an expansion of the observatory. We do have a grant from the Department of Education that we have to use rather quickly, so we're fast-tracking this project. As a matter of fact, our next meeting is on Monday to go over the latest plans of the observatory. So what we plan to do is we plan to have a ground-level observing deck for astronomy classes. We actually are Department of Chemistry and Physics with a physics program. We don't have an astronomy program as of yet, but hopefully at some point in the future we can change this. But we do plan to use this observatory for a number of activities. Title of the talk: Pro-Am Ed. I'm very fond of professional amateur collaborations, and I'm a big advocate of that. That's why it's one of the reasons why I've been attending these meetings the last several years. But we're also going to add another dimension to this, and that's ed. So as we're doing our professional amateur collaborations, we're also going to use these to educate the general public. So we're going to not only have the observatory available for use by our students and faculty, but we're also going to have collaborations with the area astronomy clubs, such as the Houston Astronomical Society, which I'm a member of, and interested members of the general public. So currently we plan to have one dome with an Astrohaven clamshell housing a 16-inch Meade telescope, and a second dome housing a plane wave 1-meter telescope. That's a recent development that we were surprised pleasantly that we actually have the extra money to purchase this. So we're going to get these set up within the next, actually the infrastructures will be set up by the end of the year. The telescope, we already have the Meade telescope. We need to get the plane wave, which if we order next month, we should get that by the summer of 2019. So this is the latest drawing of the observatory. It doesn't include the dome that houses the plane wave. The dome on the right shows the existing solar observatory. The dome that's a little bit higher is the Astrohaven dome that's going to house the 16-inch the 16-inch Meade telescope. Not shown, there's actually a trapezoidal-shaped building that's going to be the visitor center, and it has a high ceiling to enable us to install a planetarium. We may include a planetarium in the mix as well. So that's very exciting. Dr. Erickson's actually pushing that very hard. But in front of that visitor center will be another dome with an ash dome that will house the 1-meter telescope. So we're fast-tracking this. We're hoping to get this completed by the end of this year. To the right, you might see a little thick line going to the right. That's where the observing deck will be located. This is one of the early renditions that made it into the print edition of this paper that I'm presenting. We wanted to have an observing deck at the second level, elevated, sort of like the picture that is shown in the lower left part of the image. Unfortunately, that became a little bit tricky for construction, and so what we need to do is we need to simplify it a little bit to make it, to increase the probability that we'll get this done, excuse me, in time. So the observation deck was moved towards the front. and set at ground level. We still have the original in place. We'll have the, we actually were going to house the 14 and the 16-inch Meade scopes, but we decided to go with one scope, one dome instead of two scopes under one dome, and then the 1 meter plane wave. So if all goes well, again, we'll have everything built by by the end of this year. The scope would be installed. The plane wave scope will be installed in mid-2019. And we hope to have the solar observatory back online, and hopefully the sun will start getting a little bit active. We're getting the solar observatory online just in time for solar minimum, when all the active regions and the sunspot and the filaments disappear. But you can follow our progress at www.pvamu.edu/PVSO, and I'll be putting regular updates as to our progress. So some of the uses that I dream about with regards to this observatory, again, university faculty and staff, along with their students, plan to have classes there. We teach a large number of introductory physical science classes, and so we want to incorporate activities at the observatory in with these classes. Also, classes for teaching laboratory. We do offer the occasional astronomy class, but we hope to get the astronomy classes offered a little bit more frequently with more enrollment. Individual scientists within the department, including myself, working on various research projects, will be other users. Will be also using the facility, and then we'll have open houses and viewing sessions for the general public, special celestial events, for example. And area amateur astronomers will be able to take advantage of this as well. We'll collaborate with area astronomy clubs, and if there's anyone interested, there's a similar setup in the Houston area with the Fort Bend Astronomy Club and their George Observatory, which has a 1.2 meter telescope. So we might model that after that collaboration. So we're going to promote collaborations between professionals, amateurs, and educational personnel, hence the Pro-Am-Ed statement in the title of this course. And again, these are some projects that are listed, and I do plan to use some of the, try out some of the projects that I've learned about in this symposium, including deep images of active H2 regions. One of the things that we do want to do is make a narrowband catalog active regions, where we take the active regions in through narrowband, the standard narrowband filters, H-alpha, O3, and so forth, and we want to build up a catalog of H2 regions, planetary nebulae, and also supernova remnants, asteroidal and planetary occultations, and of course lunar meteoroid studies. Since the Nell Iota project in Greece has a finite shelf life, so to speak, 22 months, we can pick up where they left off with the 1 meter, with our own 1 meter telescope, hopefully get a regular patrol going on with that. And this is a nice image of M81 to the right that was taken by one of our collaborators, Doug Holland. So, so we have the, so I put in the plug for ALPO and Lunar Meteor Studies. Also our observatory, our developing observatory, which most of which should be completed by the end of the year and first light by, excuse me, mid-2019. Another thing that we're working on is a new microsatellite. Several years ago I gave a talk discussing our TENCO project, our Shine-In 2 project. That microsatellite launched with the Hayabusa 2 satellite, and Hayabusa 2 is getting ready to encounter the asteroid Ryugu. I don't know if I pronounced that correctly, but that should be an interesting encounter in the next couple of weeks or so. The Shine-In 2 satellite is currently in orbit between Venus and Mars, and it swings by the Earth every December. Unfortunately, the signal is so weak that it's very challenging to pick it up from the Earth. This is a view of the launch of Shine-In 2 back in December of 2014. And then this is the container on the left, the container that the Shine-In 2 was placed as it was launched into space. TENCO CPD will be placed in a similar container and launched sometime September, October timeframe. Just a couple of quick factoids. TENCO will actually be launched in low Earth orbit with an inclination of 93 degrees. It will be a polar sun-synchronous orbit. It will be broadcasting in 437.5 megahertz, although the actual frequency may be slightly different when we actually get this thing launched and tested out. And there will be receiving stations in Japan, Texas, Hawaii, Alaska, Mexico, Brazil, and we're also planning to set up a receiving station at the Prairie View Observatory. So TENCO is going to be launched in a similar container as shown on the left in this image, and that's actually that's actually the Hayabusa 2 satellite on the right getting ready to drop its payload. That's going to actually happen in a few weeks, so that's going to be really exciting to see the outcome. And again, this is the orbit of Shinin 2, takes it out almost to the distance of Mars. And it took Green Bank telescope, the power of that antenna, to receive the signal from Shinin 2, and we did manage to receive some information from that satellite in December of 2015. Now, the advantage of this new satellite, TENCO CPD, the CPD stands for Charged Particle Detector, and that will detect the various forms of charged particles that we see in low Earth orbit. So again, a 600-kilometer or about 320-mile orbit, inclined 93 degrees. The PVAMU payload, the TENCO payload, will be the primary. We'll deal with primarily radiation science. And this is a little bit more sophisticated. By the way, TENCO means heavenly light in Japanese. And this is a little bit more sophisticated than the Shinin 2. The Shinin 2 satellite only had 2 CMOS detectors that were set up to detect radiation hits. This will actually have 8 detectors, and the hemispherical projections that we see are actually made of material that simulates human flesh and spacesuit fabric, and there's detectors within those to map out the radiation that passes through those materials to get a better idea of the long-term exposure to humans in low Earth orbit. The silver, it looks like a silver rectangular apparatus that has the blue wires coming out of it. That's what's called a Lulin spectrometer, and the purpose of that is to measure the flux of galactic cosmic rays that come from the Earth's radiation belt. And actually, those are charged particles that come from the Earth's radiation belt, galactic cosmic rays, and charged particles that come from energetic solar particle events or high potent flares, the X-class flares. X-class is the most powerful type of solar flare in the X-ray category. So this is equipped with 8 sensors and also the Lulin spectrometer, which will be making measurements continuously in low Earth orbit. And this is a close-up of one of the sides. The circular, the washer thing on the left surrounds a detector, and then one of the hemispherical encasings on the right. And it's the circuit board is printed in Prairie View purple and gold. So again, here's another view of the device. The Lulin spectrometer was put together by a group in Bulgaria, the Bulgaria Academy of Sciences. So this is truly an international project. Another view showing the various features, the X-ray detectors, the 3D printed structure, which is the gray frame skeleton, polyethylene spheres, polystyrene spheres, the Lulin spectrometer, and an open sensor to directly measure the charged particles that hit the sensor. So this is part of the Radiation Institute for Science and Engineering. Again, this is a research lab that does radiation biology, among other things, studying the effects of radiation on human cells. We work with NASA Johnson Space Center with this. And so one of the outcomes is this satellite that will be launched sometime in September, October. I have flyers in the back. If you're interested in learning more about this, I have this information sheet, and I also have a sign-in sheet. The advantage of this particular project over the one a couple of years ago is that it should be easier to pick up the signal since the satellite is in low Earth orbit, and it will be we'll be able to listen to the signal for about 20 minutes per pass every 90 minutes or so. So if you're interested in trying to listen in on the TENCO satellite, put your name and email address, and I'll be in contact with you. I'll give you updates as the project develops and as the satellite is launched and everything gets established in space. I'd be glad to be able to share this with you, those of you that are interested in listening for the radio signals. So I'm going to stop before I run out of time, so that way people can have a chance to ask questions. And thank you very much for your attention. Yes? The total cost, it's actually a low-cost project. Right now, when you include all of the test versions, the engineering models, and the actual flight units, we have one flight unit that will be taking off, and then one flight unit on the ground for troubleshooting. We're actually talking less than $250,000, so it's a low cost. Yes. That wasn't on the initial drawing board, but that's a definite possibility. One of the things that I'd like to explore doing with this observatory in the long term, is doing things that not too many people are doing. I understand that polarization is something that's not being done by as many people as, say, like spectroscopy or imaging or photometry. So that is definitely something that we'll consider in the future. Yes, in the back. Not at the moment yet. We have identified that we're going to go with Spitz. That's the Quality Planetarium world. That's a company that's well respected worldwide. With regards to the software, we haven't yet decided on that. We're not sure if we're going to actually get the planetarium, because we still have a little bit of uncertainty as to exactly how much funding we have. But if we have enough funding, we definitely do plan to get the planetarium. It will seat about 50 people or so. It will have a Spitz projector and system, but I'm not sure what software we'll be using at this point. But you're welcome to contact me later on and find out once we get everything settled. Yes.
You mentioned that the orbit can show the sun's
Mm-hmm.
Yeah,
it's going to stay, within the same orientation with respect to the sun, so dawn to dusk. Not so much that. It's actually primarily for particle considerations. What type of particles are we going to be receiving? Because we'll be measuring. We won't be doing any imaging with this satellite, but we'll be doing mainly measuring different types of charged particles. So we wanted to have the orientation consistent with the sun as one of the objectives.
What's the power source?
The power source is that one I didn't jot down. I'll have to look that one up. I don't want to misquote you, but I can look that one up. If you want to email me, I can get that information. Mm-hmm. So again, if there's any questions concerning the mechanics of the satellite or what have you, things that I might not know right away, I can always get that information and email you. So feel free to send me an email. Thanks again.